Today's notes are on section 8.6, and we're going to solve equations using natural logs. All right, natural logs are abbreviated as LN. Let me get my pens ready. So we're going to use something called a natural log, and it's notated as LN. All right, some things that are really important that we need to know about logs that are going to help us solve equations are below. What I'd like you to make sure you do is go ahead and pause the video if you need. You need to get your graphing calculator, because in order to be able to find this letter E or the natural log, those are buttons that are going to be used on your graphing calculator. So go ahead and grab that. Okay, the first thing on part A is that this letter E, all right, so this is a letter E, is actually a number. It stands for 2.718. E is on your calculator. I want you to go above the division key. So if you look above the division key, you're going to see a yellow E. So press second E on your calculator. Second E. So go to your main screen, clear everything out. Second E, and you'll get 2.718281828 blah blah blah. So E is really a number. It's kind of like pi. Pi is a symbol that stands for a number. So E is going to be a number that we're going to use. Now I want you to show what the natural log of E is. So on your calculator, I'll write this here, on your calculator, the natural log button is the third from the bottom in the first column. All right, and it looks like LN. So I want you to press LN, and then I want you to do second the division key so you can do LNE. So put this on your calculator. LN, again, the third button from the bottom in the first row. Do second and the division key, because above the division key is E, and press enter. And what's really important that's going to happen is that LNE is equal to 1. It's fine.
I thought you were talking.
You're fine.
Are you on right now?
Yeah, that's fine.
I'm looking for an envelope. Don't worry.
Okay.
I'm so sorry.
No problem. It was just Coach Green and I having a quick brief meeting. All right, so anyways, LNE is equal to 1. That's going to be super helpful for us later to solve equations. All right. Another thing that's going to be helpful for us to solve equations is I want you to type in ln of 1. So type in ln, then type in the number 1, press enter, and you're going to see that the natural log of 1 equals 0. Both of these are going to be exceptionally important and helpful when we solve equations. Lastly, the natural log has a base of E. So before, when we did common log, I'm just going to make something up like log of x equals 2. You guys knew that the base that was there, that was, whether it was written or not, was base 10. Well, here, when we do natural logs, you're going to have, let's say, natural log of x is equal to 2. The base that's going to be there is going to be E. Now, E again is just a number. All right, so your base for natural logs is E. So with these 4 facts, we're going to use these to help us solve equations. All right, so again, make sure you have your calculator, because in order to solve and get the solutions to these equations, you're going to need your calculator. So as part A says, solve equations with E in the problem. And our goal is to isolate the E, because if we can isolate the E, it's going to make our life a lot easier. It's very similar to solving common logs. When we had common logs, like when we make an equation up here, 4x equals 5, we wanted to get the base by itself. Well, the same concept applies. I want to get the E by itself. So for problem 1, it already is by itself. There's nothing added to the side or multiplied. That is already by itself. So if the E is isolated, let's go back and look over here. If I had the common log, if you remember, I would take the log of both sides, right? But because I have an E, I want to use natural logs, because natural logs and E's have special properties that work together. So what I'm going to do is I'm going to do the same concept that I did before, where I took the log of both sides. Well, now I'm going to kind of do this in green. I'm going to put ln, or natural log, in front of e to the 3x, and then take natural log of 5. Again, as long as you do it to both sides, it's equal, right? I'm allowed to do it as long as I make the left side and the right side. Well, the reason why we do that is because natural logs properties are the same as common logs. Whenever I have this exponent up top, I can move this exponent up top out front. So I'm going to make it 3x times natural log of e is equal to natural log of 5. Well, what's easier about natural log equations, before, when I had common log equations, I usually had to divide by that log. But what's super, super awesome is, let's go back and look at right here. Hold on, I want to move this guy. Can I move that thing? I don't know. well, whatever, let's just go green. If I want to get rid of ln e, what's so nice is go back here. ln e is equal to 1. So every time I see natural log of just e, this is going to go away because it's really like multiplying by 1. So this is going to wind up being 3x equals ln 5. And your goal is still solving the equation. So your goal is to solve for x. So to solve for x, since it's 3 times x, I'm going to divide by 3. And now is when I need my calculator. I need to do the natural log of 5 and then divide by 3. It's not the natural log of 5/3, so be careful when you plug this in your calculator that you're going to put this in parentheses, ln 5, close your parentheses, or you can just press enter, and then divide by 3. Let's just round to 2 decimal places. So I got 0.5364. Let's just make that 0.54 then. So to solve the first equation, my x value would be 0.54. All right, let's look at number 2. The first thing I have to do before I take the natural log of both sides, just like when I was over here and I had to take the common log, I have to isolate the base. Well, the e is my base. There is something out front. It's 5 times that number. So I've got to get rid of that. I can't take the natural log the way it is. I've got to divide both sides by 5. So e to the 4x is equal to, go ahead and do that on your calculator. Do 18 divided by 5, and you're going to get 3.6. Now I do have my e isolated. Since the base e is isolated, I want to take the natural log of both sides. So natural log of the left, natural log of the right side. I'm going to use my properties of logs and say, hey, I can bring the exponent out front. 4x times ln e is equal to ln of 3.6. Well, ln e, go back up to number 2. Things that we know and we've learned is that the natural log of e is just 1. So this is going to go away because it's really like 4x times 1. I have 4x equals natural log of 3.6. Divide those by 4. Use your calculator at this point. Natural log 3.6. Press enter. Divide by 4 and get 0.32. Please make sure you're doing this on your calculator. Okay, don't just be following along and copying down the notes. I want to make sure you know where the ln button is and that you're also not plugging in the calculator incorrectly by doing like ln of 3.6. And if you don't put parentheses in, you're going to divide that by 4 and your calculator is going to read that incorrectly. Okay, so please make sure you have your calculator and you're going along with me doing this. All right, look at number 3. If you want to try this one on your own, go ahead. If not, stay with me. We're going to isolate our e to start. Here's my e. I want to get it by itself. I've got some junk here. Let's move over that 3. So if I have a positive 3, we're going to subtract it to get rid of it. So I have e to the x over 2 minus 1 is equal to 4. My e is now isolated. My base is isolated. So what I need to do is take the natural log of both sides. So natural log of e to the x over 2 minus 1 is natural log of 4. What you'll notice is just like before, this is going to come out front. So x over 2 minus 1 times natural log of e is natural log of 4. And every time when you take natural logs, you should set it up so that this ln e is going to go away because ln e is really just 1. So I have x over 2 minus 1 equals natural log of 4. I'm still solving for x. So when I solve for x, I've got to isolate that and get the x by itself. So let's add 1. And I'm going to use my calculator at this point to find out what that is. Now be careful. It's ln 4, press enter, then add 1. It should be 2.386. Do not do ln of 5 because that is not correct. ln of 4 is a number and then I'm adding 1 to that number. Okay? Do not plug in ln 5. If you plug in ln 5 and get 1.6, you're doing that wrong. So again, please use your calculator. Don't just follow along. I want you to be an active participant. I have x divided by 2 is equal to 2.386. To solve for x, I need to always do the opposite operation. Well, if it's divided by 2, I'm going to multiply by 2. So to get x, I'm going to take 2.386. I'm going to multiply that by 2, and I'm going to get 4.77. And again, I'm just going to round that. 4.77. Round it to 2 decimal places or the hundredths place. All right, so for part B, when you solve an equation with an e in the problem, I don't want to take the common log, the log log. I want to take the natural log. And the way you know the difference is if there's an e in the problem, we use natural log because natural log of e is 1, and that's really going to simplify our process to solve. Okay, Now, so any problems you have an e in there, isolate it, take the natural log, and solve. Now, for part C, we're kind of doing the opposite. Now I'm solving equations with the natural log in the problem to start, right? Kind of like before, I'm going to write on the side, when I had log, I don't know, of x equals 3. We wanted to isolate the log. I would tell you, hey, this is kind of your happy place because I know my base is 10, and then I can just make an exponential to solve. 10 to the third equals x. So you've done all those problems, what we just worked on homework a night or two ago. So I'm going to use the same concept with natural logs. The biggest difference is when I have natural logs, my base isn't 10, my base is e. E is just a number, all right? So if I have my natural log and I have a single natural log, I can, once I've isolated it, I'm going to make my circle to make my exponential and say e to the 5th power is equal to 4x. Well, don't freak out. E is a number. On your calculator, you can do e to the 5th. Okay, I'm going to show you a little shortcut too. You should know by now that e is above the division key. But if you look at the ln button, okay, above the ln button is e to the x. Just a minute. So above the ln button is e to the x. Why that's a little bit nicer is if I'm doing e to the 5th, I want you to try this on your calculator. Do second natural log, and that will give you e raised to the, and you're going to plug in whatever number you need. So I'm going to say e to the 5th. I'm going to find out what that number is, so 148 point so on. And if I'm solving for x, I want to divide by 4. So I'm going to take that number on my calculator, I'm going to press my calculator, divide by 4, and my x is going to be 37.10. So when you have e to the 5th, you could do second division key and you have just the plain e, then you could use your caret and raise the 5th. It doesn't matter which one you do, but this is a little bit of a shortcut to get used to. E to the x, or e to a power, is above the ln button. The ln button, again, is the third from the bottom and the first row in your calculator. So let's look at number 2. When I solve equations with natural log in the problem, I have to isolate the natural log. Well, if you look, it is isolated, meaning there's nothing added or subtracted or multiplied. I'm going to put in my base of e, and I'm going to make my exponential. So e to the 3rd equals 2x plus 1. Very similar to the common log problems. Instead of 10 to the 3rd, I'm going to have e to the 3rd. Well, on your calculator, do second ln, so I have e raised, put in e to the 3rd. So I'm going to get 20.08, let's say 55. Do a couple extra decimal places before you get your final answer. If I solve for x, if I have 2x plus 1, I have to take away 1 first. So just take away 1 from both sides. I get 19.0855 equals 2x. If my ultimate goal is to solve for x, I've got to divide by 2. Since it's 2 times x, divide by 2. And again, all these numbers are on your calculator, so you really are pressing e to the 3rd. Then you're just pressing minus 1. Then you're pressing divided by 2. All that stuff should be saved, so it's pretty easy. I'm going to get 9.54. And that would be my final answer for solving. All right? Okay, let's look at number 3. The main goal is to isolate the natural log, or get one natural log so I can make an exponential. Right now, I don't have this isolated. This is in front. So I've got to isolate it by getting rid of the 1.5. So I'm going to subtract 1.5 from both sides. I'm going to get natural log of x squared is equal to 5.5. This is my happy place. I've got a single log. I can put in the base that I know for natural logs is e, and I'm going to make my circle. So e to the 5.5 is equal to x squared. E to the 5.5 is a number. Let's use our calculator. I'm going to type in second ln, so I have e raised, put in 5.5, and I'm going to get 244.69. We'll kind of just go there. 691. I guess 692. Okay. Think about how to isolate the x. If I have x squared, the operation to get rid of something squared is to square root it. So I've got to square root the answer I have on my calculator. So square root of my answer, and I'm going to get approximately 15.64. So x is equal to 15.64. All right, so the same process, but sometimes we have to do a couple steps in order to isolate it. So look at number 4. And these problems should look so similar to what you just did on Thursday night for homework because we have 2 natural logs. And in the homework from before, you had something like, make it up, log of 3 minus log of x equals 2. And I said to you all, you need to combine those logs using properties. Then you're at your happy place. You can do 10 squared equals so on. All right, so this is the process you've done before is very similar. What I'm going to do is say, okay, I have 2 natural logs. I want 1. I have a 3x and I have a 4, and they tell me I'm subtracting them. Properties of logs are the same whether it's natural log or common log. So what I'm doing is 3x minus 4 changes to 3x divided by 4. There's my nice happy place because I have 1 log. I can plug in, I know the base is e, and I'm going to make my exponential to solve. Because once I make a natural log by itself, or get a natural log by itself, and I make my exponential, it is so much easier for me to solve. E to the 5th is going to be a number, so find out what e to the 5th is. I'm going to get 148.413. If I'm solving for x, I've got to isolate it. Well, it's 3x divided by 4. Let's get rid of the 4 first. If I'm dividing by 4, let's multiply by 4. So on my calculator, I'm going to take the number that I have there and multiply it by 4. I'm going to get 593.65, let's say 3. I'm still not solved for x yet. I've got to divide both sides by 3, and that's going to be my final answer. So take what's on your calculator, divide it by 3, round it to 2 decimal places. So I have 197.88. And there's my answer. Okay? All right, so try number 5. It's going to be very similar. So pause, do it on your own, and come back and check. All right, number 5. I have 2 natural logs. You should have combined it to 1. X plus 5 is going to be multiplied to give me just 5 times x. I put in my base of e. I'm going to say e to the 7th equals 5x. So really, I could just divide by 5, and I'll get my answer. You could do this all in one step on your calculator. You could do it in separate steps. But when you do e to the 7th, I'm going to press enter. I'm going to divide that by 5. I'm going to get 219. I'm going to round up a minute, so it's going to be 0.33. All right? Okay, the last one looks crazy, but what I want you to do is let's just go through and solve it, and you're going to see it's actually probably one of the easiest ones we're going to do. I have a 3 out front of my natural log. I always want a single log, so let's get rid of the 3 by dividing both sides by 3. So I have ln of e to the 2x equals 4. Now, for a lot of you, and this is totally fine, I'm going to show you at least 2 ways of doing this. You could say, oh, I have a single natural log. I'm going to put in my base of e and make my exponential. E to the 4th equals e to the 2x. And I know that looks weird because there's 2 e's, but it's fine. E to the 4th equals e to the 2x. Well, we've learned before, if you have the same bases, then the exponents have to be equal. Since I have e to the 4th equals e to the 2x, you could pull that apart, divide, and say, oh, my answer is going to be 2. But I want to show you a little bit of a shortcut if you know the rules of natural logs. Let's go back to natural log of e to the 2x equals 4. If you look at this closely, I can actually take my natural log and say, hey, wait a minute, I know the properties of logs say I can bring that guy out front. So I'm going to change that to 2x times ln e equals 4. And if you see something really nice happen, ln e is equal to 1. So that just drops out. I get 2x equals 4, which is x equal to 2. It will work either way. But if you understand properties, some of these problems are going to be, you can kind of make a shortcut. So just to do a little recap, you need to know these 4 things, all right? E is a number, it's like 2.718. The natural log of e is 1. The natural log of 1 is 0. And anything with ln has a base of e. If you're solving equations with e in the problem, you want to isolate the e, and then you want to take the natural log of both sides. Whereas when you have the natural log, I want to get rid of it by throwing in your base of e and isolating. All right, so make sure if you need to go over these notes again, you do so. And if you have any questions, you can just bring your notes to class and we'll answer them.